Hello, welcome to the lecture on 8086 microprocessor. I am Dr. S.M. Shamshirdawala, Department of ECE, G. Pullareddy Engineering College, Kurnool. Today, we would like to present the details, features, and architecture of 8086 microprocessor. Previous discussions were carried out on 8085 microprocessor. Both are Intel product microprocessors. So this session, let us start with comparison of 8086 with 8085. The complete session will be overlooked with simple arrangements like this: comparison between 8-bit and 16-bit microprocessors, then architecture details of 8086 microprocessor. As having a discussion presentation earlier to show, to learn about any microcontroller, any user or learner can go with few representations, like we can learn the architecture, we can learn the programming model, we can learn the timing diagram arrangement to know about any sort of microprocessor. Then in continuation, before representing the architecture of 8086 and pin diagram of 8086, the very first thing we would like to focus is features of 8086. All the features of 8086 are brought from the previous version with an extension to the later version. Now we can see on the representation is similarities between two microprocessor 8085 and 8086 are represented here, as both are developed by Intel Corporation. 8085 is 8-bit processor and 8086 is a 16-bit processor. And data lines are also been extended similarly from 8-bit to 16-bit. Address lines are enhanced from 16-bit to 20-bit. Memory addressable using the 20-bit address lines is extended up to 1 MB. The frequency is also been enhanced from 3 to 5 megahertz. Now it is in 8086 as 5 to 10 megahertz. But we see the similarity, like both are consuming the same power generation, 5 volts VCC supply. This could be a plus point to 8086, like using similar voltage, similar power supply, it is giving a high-end performance compared to 8085 microprocessor. Another specialty with respect to 8086 is it is having the same 40-pin IC structure as compared with 8085, and it is also having many more enhanced features. Some of the specialties, some of the new things that were being added through 8086 microprocessor, which makes microprocessor 8086 as a revolutionary processor in the processor technology generations. Few represented specialties are memory segmentation concept, physical memory organization concept, through which we got pipelining from parallel processing concepts, which generated multi-processing facilities. Now, if we look into the insights of 8086 features, it is as simple as to be learned through any learning procedure. It is a 16-bit microprocessor developed by Intel Corporation, which has its own enhancements compared to 8085 microprocessor. What all the good names we might have noticed with respect to 8085 registers, architecture details, we find many such similarities with respect to 8086 also. The data registers in 8086 are of 16-bit size, and address registers are of 20-bit size. Here, data that is being held in 8086 will be treated as 16-bit data, or in other terms we call it as one word. 2 bytes is considered as one word here. We might have seen many registers with respect to 8085 which are very much familiar. One of the good name going like accumulator. 8-bit register accumulator was represented as A in 8085. Somewhere in 8086 we will be using the same name, such like accumulator, which is the most prominent processor register. Yet the representation of accumulator in 8086 is been modified. A in 8085 is also termed accumulator. Here also it is termed accumulator, only the representation varies, as accumulator size in 8086 is 16-bit. Now it is called as AX. Sometimes we can use accumulator AX in two formats: 8-bit arrangements, lower byte of accumulator and higher byte of accumulator, termed as AL and AH respectively. Each of this accumulator representation will be of size 8-bit data capacity. All these three names, AL, AH, and AX, will be simply termed as accumulator. So names repeatedly might be seen with respect to 8085. Maybe if I use the word called flag register, we might see the same name again, but sizes of the registers will vary with respect to 8085 and 8086. So now going strictly with respect to 8086, we are having the other inner details saying like it is having a frequency of 5 megahertz to 10 megahertz. Then it works on a 5 volt supply. Then the available address lines for 8086 are 20-bit. Now we can see it can easily map using 20 lines, saying like 2 power 20 memory lines. It can map up to 1 MB of memory. Still, there is some speciality with respect to 8086, which says like using only 16 bits of addresses, it can map up to 1 MB of memory. This is a part to be focused in the further discussion. Then as mentioned again, flag register of 8086 is also extended with respect to the same name flag register of 8085. The size now becomes from 8-bit to 16-bit. With these known factors, if we look over the architecture of 8086, it goes something like this. As mentioned in many earlier discussions, saying like whenever we need to learn about the architecture, we always prefer to start from its execution unit. So one of the most prominent part of execution unit is its ALU. So if we consider this block as EU, one of the most prominent part which decides the designation of the processor, our processor is a 16-bit processor surrounded by nearby processor registers and IO lines. One of the most other sophisticated register that is arranged to the ALU is always a flag register. Now we can see in a representation here showing like what all the possible execution unit components we can fit inside this block, saying like processor register, whichever are conveniently used at the execution time, are being represented here. One of the example is shown on the left side, a register set represented as accumulator by name and shown in arrangement as AX, sometimes AL, sometimes AH. Other similar registers that come in the countdown here will be BX, CX, DX, which have got their own names based on the letter A after accumulator. They have their own peculiarity and specialty apart from being general purpose registers. Few more registers that we can see in the execution are known registers, stack pointer register, base pointer register, SI and DI 16-bit general purpose as well as address registers. SI stands for source index and DI stands for destination index register. SI and DI can be considered as address registers and sometimes they can also be used as general purpose registers. Now the upper blocks which are empty in our discussion can be represented like this. Whenever data is required for execution, it has to be first decoded and we have the CU unit to decode based on the clock cycles provided to the device. Then we have the bus connections which are going to get us with our information, something like fetch the data, fetch the instructions through some address mapping capacity. And what is the capacity of address lines and data lines 8086 supposes are being shown as 8086 has 16-bit data lines and it has 20-bit address lines. 16 data lines and 16 address lines are multiplexed with each other. Data is shown in fat bidirectional arrangement there and address is shown in unidirectional arrangement there. One of the other speciality that adds is prefetching the instructions in prior situations, and one unit called prefetch queue unit, which is of 6 byte size to 8086 architecture, is also a new factor in the design. So all these, when they are interlinked with each other, they show a complete architecture arrangement of 8086. So here we take a break for the discussion. We stop here showing the features and architecture of 8086. In the coming discussion, we will look the insights and pin structure of 8086 architecture. Thank you for this.